Hello everyone. We are now going to work on Chapter 1, Lesson 5 for Robert Morris University Math 0900. This is Brianne Pernick, your instructor for the course. In this lesson, we are going to learn how to use the order of operations to help us simplify numerical expressions. In order to use the order of operations, it's important for us to understand what they are and why they were established. A long time ago, way back when people first started doing mathematics, mathematicians were solving problems in a variety of different ways and getting a variety of different answers. And it came to the conclusion that it needed to be more orderly so that number one, everybody was getting the correct answer and following the same steps. And number two, we need to make sure that we are teaching people the correct way to solve the problems so that they aren't just going about it the wrong way. So the order of operations tells us the way that problems are supposed to be solved. So the very first step that we are supposed to take whenever we're solving problems is to do any and all operations that are located inside a set of parentheses. After you take care of any of the work that's inside the parentheses, the second thing that you would want to do is anything that involves an exponent. After that, you would take care of any multiplication or division from left to right. It does not matter if the multiplication or division comes first. You do whatever comes first from left to right in your equation or expression. And then lastly, you would take care of any addition or subtraction in your number, or in your equation or expression, from left to right again. If the addition comes first, you do it first. If the subtraction comes first, you do it first. Now, there are some helpful ways to help us remember the order of operations. A lot of people remember it by remembering the acronym, Please Excuse My Dear Aunt Sally, where each letter in that phrase represents an operation in the order of operations. So the P is your parentheses, exponents, multiply, divide, add, subtract. I like Please Excuse My Dear Aunt Sally. I learned that as a child and never forgot it. Some people just memorize the word PEMDAS. The word PEMDAS, again, stands for each of the operations, and it helps you to remember what you should do in a problem in order. Now, what I found to be interesting was one day I was flipping through my radio stations in my car, and it was a morning that I was driving to work, and I had KISS FM on. And Mikey and Big Bob, who are the radio DJs for the morning show, happened to have a contest on their Facebook page that required you to solve a problem using the order of operations correctly in order to win a prize. And I was thinking to myself, wow, what an easy contest to try to enter into there. I'm not one to enter into stuff like that, but I did take a look at it. I was amazed at the number of people that were solving the problem wrong because they clearly did not know their order of operations. So, I mean, you never know. Learning your order of operations correctly could win you a prize on a radio station. So let's take a look at how we can apply the order of operations to some of these problems to make sure that we know what we're doing. Now let's remember the steps. Please excuse my dear Aunt Sally, or PEMDAS, however you want to remember it. The first thing that you are always supposed to look for are parentheses. If there are no parentheses, you look for exponents. If there are no exponents, then you would move on and look for multiplication or division. Our problem in letter A does contain some multiplication. So we're going to go ahead and start with the multiplication of -4 times 3. Everything else in your problem does just need to come on down into the next line. And when we do -4 times 3, we do get -12. So you're going to write -12 because that was the answer to that little problem that you just took care of. When you put the -12 back in there, that now creates a subtraction problem. 2 minus 12 is -10. And we now have the correct answer to that problem. Letter B, you start over with your order of operations. You're going to look for parentheses. We don't have any. You're going to look for exponents. We have one right there. So everything else in your line that you are not using needs to come down into your new line. 5 to the second power makes a positive 25, so you are going to write plus 25. Next, we're going to take care of multiplication and division from left to right. The first thing that you encounter is division, so you do that first. 12 divided by 2 is 6. You rewrite your line and bring everything down. In algebra, we do work vertically from line to line. The next step that you have is multiplication. We take care of that. 6 times 3 is 18. We bring down our positive 25. And now we have one more step, and that is addition. 18 plus 25 is 43. And we have the answer to that simplified expression. Moving on to letter C, we're going to start by looking for parentheses. We have a parenthesis, but the only purpose that that parenthesis is serving is to tell me that -3 is the base to an exponential problem. So I'm going to evaluate that. Since the exponent is odd, I know my answer will be negative. 3 to the third power is 27. I'm going to bring down my minus sign. 2 to the fourth power is 16. Now I'm going to look at my next problem. I have -27 minus 16. If you notice, you have two negatives. When your signs are the same, you keep the sign and add your numbers. Remember, I simplified that down to just 2 sets of rules for you guys to remember. So 27 plus 16 makes 43. We get -43. I would like for you guys to try letters D and E on your own, following the rules following the order of operations, Please pause the recording and take a minute to simplify D and E. Okay, at this point, everybody should have paused the recording, solved D and E, and now we should be prepared to check our work. So the first thing that you need to do in this problem is take care of the math that is in the parentheses. So we're going to start by bringing down the 2, bring down the multiplication sign. 2 minus 3 is -1. Since that base is negative, I am keeping it in the parentheses. I need to bring down that cube, bring down the 6 divided by 3, plus 8 minus 5. We have another parenthesis. Let's take care of that. We get 3 squared. The next step tells us that we need to do anything that contains an exponent. So I'm going to bring down my 2, bring down my multiplication sign. I have -1 to the third power. Since my exponent is odd, my answer is going to be negative. 1 to the third power is 1, and I have -1. I am leaving the parentheses in there for cosmetic purposes to show a separation between the multiplication sign that I wrote previously and my negative. Now I'm going to bring down the 6, divide by 3 because I am not ready to do it, and then lastly I have 3 squared, which is 9. My next step is multiply or divide from left to right. So 2 times -1 is -2. Now I have some division that I can do. 6 divided by 3 is 3. And then I'm going to bring down my 9. And now I have some math that I can take care of. Oh, I made a mistake there. That is 2. Sorry. 6 divided by 3 is 2. Lastly, I am going to add. So we have negative 2 plus 2, which makes 0, plus 9 is 9. Letter E, the first thing that you should have done is taking care of your math inside parentheses. So we have 5 plus 2 times negative 2 to the second power minus 18 divided by 2 plus negative 1 cubed. Now you take care of your exponents. So we have 5 plus 2, negative 2 squared is 4, minus 18 divided by 2 plus negative 1. We evaluated that exponent. Now we are going to multiply and divide from left to right. So we have 5 plus 2 times 4 makes 8, minus 18 divided by 2 is 9. And I'm going to bring down my negative 1. However, I do want you to notice that you can rewrite that as simply a minus, because plus a negative is exactly the same thing as subtracting, and we can simplify that by writing minus 1. We do not need to write that plus sign there. So now we can take care of this addition, and I'm actually going to start by using my associative property that we talked about before. I'm going to combine my positives. 5 plus 8 is 13, and I'm going to combine my negatives. Negative 9 and negative 1 makes negative 10. Now I have a simple subtraction problem. 13 minus 10 makes 3. How'd you do? If you're having trouble with these problems, please let me know. Moving on to problem F. In this particular problem, the first thing that you have here is an exponent that you should take care of, because all of these parentheses are just here for cosmetic purposes. So I'm going to bring this stuff down. I'm not doing anything with it yet. And then I'm going to evaluate my fraction. 3 squared is 9, and 2 squared is 4. Now I'm going to take care of my multiplication. So we can straight multiply these fractions, and this is a positive. I'm sorry, I don't know why I wrote a negative there. So we're going to straight multiply these numerators. Negative 1 times 1 is negative 1. 5 times 2 is 10, minus 9/4. We do have to find a common denominator. We should use 20. So since both fractions are, so bring down your minus and your negative. The first fraction had to be multiplied by a 2, so 1 times 2 is 2. The second fraction, we needed to multiply by a 5 in order to get that denominator. So 9 times 5 makes 45. I told you that when your signs are the same, we're going to keep the sign and add. So 2 plus 45 makes negative 47/20. You do need to convert that into an improper fraction. When you do so by setting up your division problem, you should get 2 7/20. We have one more problem to go here, and it requires us to do pretty similar steps. Now, we have an odd exponent and a negative base, so our answer is going to be negative. 2 to the third power is 8. 3 to the third power is 27. Next, we can multiply, but we can also cross cancel. 7 becomes 1, 3 becomes 21, 10 becomes 2, 15 becomes 3, cross canceling by a 5 there. We can straight multiply. 2 times 1 is 2. 3 times 3 is 9. You will have to find a common denominator. Let's use 27. And lastly, when you multiply by 3, you'll get 6. When your signs are different, you subtract. You should get, negative 2/26. sevenths